This is a gate problem from electrical engineering, and it's from circuit theory module. So the question is stated as follows. The impedance looking into nodes 1 and 2 in the given circuit is option A 50 ohms, option B 100 ohms, option C 5 ohms, and option D 10.1 kilo ohms. And this is the corresponding circuit. So this is a problem that is primarily based on concepts of KVL and KCL. And if you look at the circuit, although it's not important, but if we look at this part of the circuit, we can understand from our concept from analog electronics that this represents the small signal model for a BJT, especially when you consider that 99 is the value for beta. Anyways, what we have to do here is to find out the impedance looking into nodes 1 and 2. And the way to proceed with these sort of questions, whenever we are asked to find out the impedance looking into some node, is to do the following. So within those two nodes 1 and 2, just connect a voltage source and call it as V, and the current that flows through, name it as I. And the input impedance or the input resistance by definition will be the ratio of V to I. So our target is to find out the ratio of V by I for this particular circuit. Now let's see what we can find out from the given problem. So number one, we know that this current is equal to I, and another current that is entering this node, this particular node, is 99 times IB, where IB is the current that is flowing through this 1 kilo ohm resistance. So the current that goes out from KCL, we can formulate it as the summation of small I and 99 times IB. So the current that flows up to this node is equal to I plus 99 times IB. Now from this other side, IB is flowing. So the outgoing current from this particular node will be summation of IB plus small I plus 99 times IB. And we can symbolically represent it as capital I. Now again, if we look at this part of the circuit, we find that here is a resistance of 0.1 kilo ohm, and the voltage across that resistance is given by small v. Therefore, capital I can also be written as small v, which is the voltage drop across this resistance, divided by the value of this resistance. So small v divided by 0.1, and this is equal to 10 times small v. Note that I have taken the resistance as 0.1, and I am assuming that I will be using all the resistances in the form of kilo ohms, and therefore the current will always be represented by milliampere in my circuit. Okay, next, what we can also do is we can proceed with this loop, this particular loop, and frame a KVL equation for this loop. So what we can write is that this current is IB. So the voltage drop across this 9 kilo ohm resistance will be 9 times IB, and then the voltage drop across this 1 kilo ohm resistance will be 1 multiplied by IB. So 9 IB plus 1 IB plus V should equate to 0. This is from KVL, and therefore the relation between IB and small v is given by IB is equal to negative of 0.1 multiplied by small v. Now from here we have found that capital I is equal to 100 times IB plus I, which is the same as 10 times small v, and therefore if we write this equation like so, 100 IB plus I is equal to 10 V, and then we substitute the value of IB, which is equal to negative of 0.1 V, in this expression, in this equation. So we get 100 multiplied by negative of 0.1 V plus I is equal to 10 V. And if we go ahead with solving it, the ratio of V by I is equal to 1 by 20. Now note that the current is in milliamperes, and therefore the unit for this will be in ohms, but it will be in kilo ohms, because this will be voltage divided by milliampere, and therefore the answer turns out to be 50 ohms. So option A is the correct answer. But the takeaway point from a question like this or similar patterns of questions are that you have to connect a voltage source from whichever nodes you are trying to find out the input resistance, and then take the ratio of V by I. Rest of it is a simple case of using KVL and KCL and solving the circuit.